Okay, we're back. This is the second part to that first video. My phone died, or the battery died, so we had to cut that one short. But I've had this amp now on the bench warming up for about 10 or so minutes. We have about 310 volts on the HT, which is good, as most of these EL84 amps get abused. This is the first one I've seen that had a decent HT voltage. The last one, the Seymour Duncan that I had in here, which is an oddball of an amp, only ever seen one of them, that had 400 and something on the HT. It's an EL84 based amp. And like most of them, the EL84 seem to cop the abuse. Anyway, so 310 volts is good. What I am going to do now, though, is measure the voltage across each side of the output transformer. We've already measured the resistance. We got 105 on one side and 116 in the other. Let's have a look at this. So on one side we have 1.3, which would be, let's see, 0.3 divide 104.8. It's only 12 milliamps. Then HT of 309, and we'll take out, so let's say 308 roughly for the plate to cathode. It's only about 3.8 watts of power dissipation, which is way too low. The other one's not going to be that much different because these valves are actually fairly well balanced. Let's have a look. Okay. And the other one is 1.46. So that one's only slightly warmer. Let's have a look. 1.46. Let's just write that down. Or 1.47. Actually, it was 47 divide 116. 12.6. Or 12.7, I should say. So that's not much either, right? So let's, what was the power dissipation in this one? So we take out 1.5 volts, so about 308 volts on the supply, on the plate to cathode. Around 3.9 watts. So 3.8 and 3.9 watts. So what we're going to do now is increase that a little bit. And just before we do, what I'm going to do is check the control grid. Let's check the screen grids. Okay, here that's pin 9 on each one of these. Let's have a look. 305 on that one and 305 on that one. Let's just write that in. ESL 305, right, the SR 305. Okay, so we're going to warm these guys up a little bit as they're running way too cool, less than 4 watts. So I want around about somewhere between 6 and 7 watts, so which would be 60 to 70, no, a little bit more than that. What are they? Plate dissipation on EL84, I think it's what, 12 watts? So if we can get 6 watts, that'd be 50%. Anything more would be better. Slightly more. I think 70% is the maximum I'd want on an EL84. So I can get this in there. That's it. So turn this down to a 20 volt range, and then we'll adjust over here. Let's turn that up a little bit. Going around. So let's go to 2.3. Okay. There we go. 2.3. And what are we going to get now? 2.3 divided by 104.8. 104.8. 21.9. That's not bad. What's our B plus now? 292. So we'll take off a couple of volts, so it's 290 across the plate cathode. So times 290. We're at 6.3 watts. 6.36, I say 6.4 watts. And let's have a look. What do we have on the other one? Okay. On the other one, which I think is going to be slightly warmer, we've got 2.66. 2.6, 2.7, 2.6, 2.6, close enough. 2.6 divided 116, that's 22.4, yep. And times 290, roughly. So 6.5 watts on that one. That's actually way better. So that's around 54% of the total bias. Like I said, maximum these should be around 70 for a fixed bias amp. You push it a lot higher if you're cathode bias, you can get it to 100 or close. But the good thing about this amp, it's not abusing the EL84s, and the plate voltage is only around about 290, which is great. I'm just going to double check this again. Yeah, 2.6 or so. Let's check now our control grids, which we can leave that there. That's going to be pin 2. So I think I measured these off camera, and they're around about 14, minus 14. So let's see, pin 2, minus 10.6, and minus 10.6. So VGL, L is for left and R is for right, at least the way I see them. So minus 10.6 volts, 6 volts, not bad. I already measured the preamp section, including the cathode follower. This is a cathode follower that drives a tone stack. It has around 46 or 47 volts on the cathode, which is not bad. And one thing I do want to check right now is the actual ripple voltage on the B plus or HT. Let's have a look at that. So you guys can't see this, but I got a Fluke benchtop multimeter sitting over here, which is AC powered. It's an older one, but it's super accurate. Let's put that to AC, and we'll drop this down to about 20 volt range. Let's see what happens. I would expect a few volts of ripple settling down. I'll give that a half a minute or so. We're at 2.6 RMS, 2.6 volts RMS, still settling down. Still 2.6. While it's doing that, I'll just double check this again. Make sure it hasn't moved. Yeah, 2.6 on that one. It doesn't really matter if it's negative here. 2.3 on that one. So our ripple seems to have settled down to around 2.3 volts RMS. Actually not bad. I was expecting higher given the capacitor is at least 20 years old. Doesn't look like it's been replaced. Looks like it's factory solder joints. Yeah, 2.3 volts, 2.3 bits, between 2.3 and 2.4. It's actually pretty good. We'll say 2.4. That's a peak voltage of what? 3.4. You just take the RMS and you multiply it by √2, because RMS is kind of like, I'm going to say the average, but it's not the peak. We want to know the peak. I think average is what? 0.6, no, I'm getting that confused with something else. Yeah, so root 2 is 1.414, yeah. My memory serves me correctly from my engineering degree. RMS is just the value of that you would have if you put across a resistor power. If you take the AC and you would actually convert it to DC, that's the equivalent power dissipation in that resistive load. Yeah, it's settled around 2.3, between 2.3 and 2.4. Well, like I said, we'll take it at 2.4. That's actually not bad. Let's check the control grids one more time. Around about, what, 10.6? It's going to be pin 2. Slightly less, it's good. Slightly less. The valves are really well balanced. Super well balanced, okay. Well, that's how you bias this amp, this little Laney TT20. Like I said, I fired this thing up before. There's no scratchiness on the pots. There's no objectionable hum. The reverb tank's in good condition. I think it's an Accutronics reverb tank that actually works quite well. It's not transformer driven, it's valve driven. I think the owner just, yeah, like I said, the owner just wanted a once over on this amp just to see how it was all working, to make sure there's nothing funny happening inside here. And it's all good. Very surprised. Whoever had it before him actually looked after it really well. Current guy wants to use it as a practice amp and a recording amp. And he's done well, given he's only paid a not so large amount of money for it. So good for him. Okay, I think that wraps it up for this. Hopefully the video wasn't too bad. Leave a comment, even if it's a negative one. What can be improved? What did I do wrong? What did I do right? Give it a thumbs up, subscribe, and hopefully I'll get some more videos out as I get these amps in. Like I said before, I want to get these recorded, not just for YouTube but for customers to see what I've done. To take a look at the amp so they can see that this is what it looks like on the inside, not just my word. Okay, thanks for watching, and I'll catch you guys on the next one.